Hello, everyone. Welcome to the ninth episode of the Day Zero podcast. I'm Spectre, and with me is Z and Anti. And yeah, so we're just going to jump right into the first hardening and mitigations topic that we have set out. So we have an unhackable chip.
Yeah,
So
codenamed Morpheus. Well, I guess
Morpheus.
not codename. That's actually what they're calling it. It's a architecture. I didn't actually write down what they had based it on, but it was based on some RISC chip. But
Oh, okay.
first thing to mention here, this does not it's not an unhackable chip, as pretty much anybody could guess by reading that title. It's just wrong.
Absolutely
And I mean, yeah,
unhackable.
coming out of this is umichigan.edu. It's one of their official posts here, and I mean, they jump right into it with unhackable. And the whole description that they go through with this involves um I mean, it's not inaccurate, but it's completely misleading as to what you can actually do or what this chip actually does.
Yeah,
Um
so I remember I asked you just before the stream because there's actually a white paper for this as well, and the white paper doesn't claim that it's unhackable, but the article does.
Yeah, so the white paper is a lot more modest and a lot more accurate as to what this chip is actually supposed to do and what it actually does and how it does it. Unfortunately, we don't have the link to the paper. It was up on Sci-Hub, but I can't. It wasn't working right before the stream, so I was able to pull it down right now. But and the only other place it's really on is right from ACM, Advanced Computing Machines, I think, like where the paper was published. So you can pay like $100 to read it there if you want. To
Okay.
avoid that, though, basically what they claim, it's a quote from the paper, is Morpheus is designed to mitigate control flow attacks, many of which utilize memory exploits. Specifically, we seek to thwart attacks where a trusted but vulnerable victim processes untrusted inputs that exploit memory errors to hijack control flow of the victim. This is a control flow issue, or that's what they're trying to mitigate. So when you jump around to uh, jump onto the stack to execute shellcode. I mean, sure, we've got other protections for that, but that type of thing.
Okay. Yeah, so I saw one quote from the article, which, by the way, do we just want to bring that up on the stream so that the viewers
Uh,
can see it there?
like, what do you mean? Oh,
Oh,
sorry,
yeah,
Rabbit. I just forgot to
yeah,
bring Rabbit up.
yeah, no problem. But the one quote I saw was that it basically it reshuffles bits of data and code 20 times per second, which is that actually what happens? Do you know?
Potentially, yes. Actually, that is one of. So this is actually kind of an interesting architecture. Up front, I'll say I don't think it's going to catch on or anything, but it's definitely an interesting idea. Yeah, so it can potentially be shuffling it 20 times per second. That's actually customizable, and there are
Okay.
other things that can cause it to go a lot quicker. So a really quick rundown on what this actually looks like is, first of all, one of the things it does, it adds 2 bits to every word. So 64-bit wide register, now there's 66 bits wide. 2 bits are added to everything.
How does that work?
Uh
That's
but
weird.
that goes
Okay.
to, this is an architecture level thing. This is the chip that's implementing a lot of these defenses, and that's where it definitely differentiates itself. So what they do though with this is those 2 bits are used to tag every piece of data as either being code, data, a code pointer, or a data pointer. So essentially, if it knows what's a pointer to code, what's a pointer to data, and what's just code and data, so it's able to reason about what's going on. And what it does is there are three kind of protections that are implemented. Pointer displacement. I'm just using the terms that they've gone for. Essentially, it obscures pointer values by adding a random offset to them. This is domain specific, so your code pointers will have a different offset added to them than the data pointers, which will also have their own. So that's just making kind of the pointers a little bit more difficult to predict. Then data encryption. I don't have the details on how the encryption actually happens. I can't imagine it's terribly complicated. just given how everything else works, I'm assuming they do another like random offsets being added to all of the data, like the code and data, or just data actually, I think. Either way, so I don't know exactly what that looks like. I can imagine just doing that, just kind of reuse the code.
Okay.
But yeah, so it effectively encrypts or randomizes the data values there too. Again, it knows what's data, what's code, and all of that because of those tags that get added. This requires a custom compiler, of course, too.
Okay. It sounds like a very neat idea, but what I wonder about is if it's doing it that many times per second, like how impactful is that on performance?
Well, so that's the thing. If you want it, I think they were talking about at the performance level as only being a couple percent off the CPU. So like
Okay.
not huge, but at the same time, like at that speed, it's not necessarily like given how fast the computer is going to operate anyhow. I mean, you're going to be able to leak an address and reuse it within 50 milliseconds is what they use for a lot of the demos. Like that is a pretty long period of time when you're talking about a machine that's executing at gigahertz, not that like it's executing quite quickly. That said, those are kind of the what they call their moving target defenses. Basically the pointer displacement and the data encryption. As I've kind of mentioned, this is architecture level, not code wise. So the code never needs to decrypt those pointers. Because you can definitely see some similarities between this and encrypted pointers.
Yeah,
Or at
I was
least
gonna
I
say it
did.
kind of sounds like Pack. Yeah.
Yeah, well, so with Pack, you've got the authentication also, which definitely I saw some similarities with that. They're definitely different though.
Oh yeah.
But just encrypted pointers, not just authenticated pointers. So I think Pack is authenticated pointers, correct?
Yeah.
It adds the tag onto the front.
Yeah, it does. Yeah.
Yeah. But the pointer itself is still technically raw, whereas this just modifies the value of the pointer. Really similar though in concept, but in terms of it validating something. Again, so anyway, as I'm getting at here, the code doesn't need to ever decrypt the value of the pointers. So it never needs any way to look up where things are actually stored or what things decrypt to or what the key is. It doesn't need to know that. So the magic sauce, though, with this chip is what they're calling the churn unit. And so what that does is it will... part of it is that it will periodically re-encrypt the pointers. To be fair, like the mitigations we've talked about that implements right now, they are actually pretty good mitigations. This churn unit though, because it has knowledge or because it's able to see what type data everything is, it's able to iterate over everything and re-randomize everything. So it does that periodically. And they mentioned that every 50 milliseconds or so. That can be adjusted if you depending on performance. Of course, if you go faster, performance takes a greater hit. It doesn't stop the program to do this, which I think is one interesting aspect. It's not like a garbage collector that pauses everything.
Okay.
I didn't get into how exactly that aspect of it works, but that is one of the things they're mentioning is it doesn't stop the program. So I'm assuming there's probably just, it keeps track of some state, like how far in memory it has translated in, and that it's able to look it up.
I was gonna say, because without pausing it, I could definitely see there being race conditions there that could be really bad.
Yeah, well, that's definitely like getting hands-on with this, because I definitely see like there could be some issues. In theory, a lot of things sound great, but I'll touch on those a little bit more. One of the other things, though, instead of just running that periodically, more dangerous, I think, or it also has these rules that will cause either a churn, which is when it re-randomizes, or it has some abort rules that'll just cause it to abort or terminate the program. It'll abort if you try to execute anything that isn't tagged as being code.
Okay.
It'll abort if you and I mean that one pretty much expected. That's pretty similar to what you've got already with data execution prevention, or NX.
Yeah.
Using code as data in any of the instructions, again, because it can see these tags when it's processing the instructions. It can see, hey, you're doing something with code, you shouldn't be using code like that, and just terminate. Jumping to something that isn't a code pointer, or doing a load or store with a non-data pointer address or argument. So those will cause it to abort.
So
Now,
that could prevent like ROP chains and stuff like that then, technically.
well, so your ROP chains,
Like if you were saying
it'll
like if you
cause
try to
some
jump somewhere that's
complications. Well, so
yeah.
your ROP chain, so you're jumping into code, you're just reusing code. But it's still technically, if you're able to craft a pointer to wherever you want in memory, your ROP chain's still going to execute because it's still a pointer to code. But creating that pointer can be a problem. And
yeah, that's what I was thinking of. Yeah.
And then to add to that, though, there's the churn rules that cause it to do this re-randomization. So not just is it scheduled, but anytime you perform an inter-domain comparison, so anytime you compare like to a code and a data pointer, I think would be the most common case, it'll re-randomize. Any pointer arithmetic whatsoever of code or data pointer arithmetic, it'll re-randomize after that. If an overflow occurs, it'll re-randomize. And if you do shifts by a length greater than 64 bits or whatever, presumably if they have some other architecture like 32-bit one, it would be 32 bits, but it'll re-randomize again. So effectively, there are a bunch of things that cause this to re-randomize. And that's probably where you're going to see some difficulty, like with crafting the ROP chain, because you have to do that without doing any pointer arithmetic. Otherwise, your old pointer becomes invalid.
Yeah, that sounds like a massive pain in the ass for exploiting any memory corruption.
Absolutely. That was kind of my thought. Like, despite the terrible report or like publication, the chip itself, like, this would be difficult in theory, at least, to exploit. That said, you already kind of touched on the race condition idea. Would it be possible to say, or how does it know what data, or does it know what data is attacker controlled? So can I get something, if I have a pointer in a register, will it automatically overwrite it for me? Can I abuse that to have it translate something like, instead of focusing on getting the ROP chain and everything set up, can I just focus on getting my leaked memory into a register or into somewhere that it'll translate it again?
Yeah.
Things like that. Like, without being hands-on, it's really hard to say what will happen. But definitely kind of interesting, nonetheless. Just, like, as a chip, these are some really strong mitigations.
Yeah, so I saw some comments on the article, and they were really, unhappy. A lot of people were unhappy with the unhackable tag because this does do a lot to binary stuff. But there's some other attacks you can pull off, like bad API or something like that, like higher
Anything
level
higher level, yeah.
Yeah. But against binary, like this is actually a lot more effective than I originally thought it was. Like,
yeah, like,
knowing
I
all
mean,
this
your
information.
DOP type issues, your data-oriented attacks, are still going to be around, but those aren't really very common. Like, that's still a reasonably new technique.
Oh, I can't say I've ever written a DOP chain actually.
Nor have I.
Never
I've
needed
read
to.
the paper. I've not actually done an exploit needing it. So,
Yeah.
but I mean, those, because that doesn't violate the control flow, that's still going to be around because control flow integrity isn't violated. And this really only stops things where you need that, where control flow is being violated and where you're needing to leak that information, which is less of an issue with some of the DOP stuff. Actually, I guess it can actually toss a couple hurdles into the DOP things, as I'm thinking about too. Just in terms of where your memory is and what you're able to do. But either way, it is effective. I absolutely agree with you on that. Or binary.
Okay. Yeah. So basically, the article is just don't consider the title. I think the actual like text of the article is okay from what I read, but like the title is just crap.
I mean, it talks about things like, I guess right in the title there is it stops attacks, and it talks about that a little bit. And to be fair, like, it's not wrong, it's just misleading. Like, yeah, the abort would totally stop an attack, or so would some of the churn stuff. Like, it's technically accurate, but it's absolutely misleading.
Yeah. So just jumping back a little bit, I know you were talking about some control flow integrity stuff. So we actually do have another white paper on, that mitigation. If we want to jump into that.
Yeah,
So,
the DeepCheck. Do you want to talk about that, or should I?
Well, one thing I should say is this kind of scares me as an exploit developer, because I read through it and it seems just one second.
It seems like you're getting a call.
Yeah, I'm getting a call.
They
Yeah.
they want to join
Um,
us.
yeah, they do. No, it kind of scares me because when I read through it, I noticed it said it doesn't have any like overhead, or at least the overhead is very small. Um, it does assume some mitigations are enabled, like data execution prevention, but that's kind of a given on any like modern system. Um, and basically, from what I gathered, they create a bunch of negative samples to create like ROP gadgets that are
Yeah,
flagged as malicious, and they basically kill the program.
yeah. I mean, basically, this is where like they talk about as being like a neural network and deep learning, and I mean that's where it's really important to remember that ultimately this comes back down to statistics. This is
Yeah,
essentially statistically, is this likely to be malicious or is this likely to be legitimate? In terms of the performance, yeah. So it's only on Intel processors because it takes advantage of Intel processor trace, which means that it records the control flow just into these little packets in memory that don't get cached or anything. Um, so that's where it's not having any runtime overhead, but it's also not necessarily going to be 100% accurate because, like I said, this is statistics based. But
that's
yeah,
true.
that's the gist of it. Is you have your runtime or you have your training run where it sees like a bunch of legitimate, or you can give it some illegitimate ones to train it with. But so it knows those are benign, those are okay, and then it looks for anything that violates that, just anything that's statistically an abnormality.
Yeah,
Definitely could be effective. Requires that training though. They've mentioned detection accuracy as high as 98.9.
yeah. So I was gonna say, like you said, it's not gonna be perfectly accurate, but the rates of failure did seem pretty low. Like it was 0.15% false positive and 0.60% false negative,
Yeah, no,
and
definitely. I mean,
like
I've looked
that's
at
pretty
this,
good.
or I had a thought of doing something really similar. Like, obviously, I don't know about the chip stuff, so I was looking at trying to do this more software, more just like this is something that could be done. And I
Yeah,
mean, seeing this now with the Intel processor trace, like that definitely makes this something that we could see, at least on hardened systems, that people can start adding in. Because it will catch in a lot of cases. It's not going to catch, it would be difficult to do with like a lot of JIT systems. Anything that's kind of doing some just-in-time compilation, it's going to be a
yeah.
lot harder to find the um, proper graphs just because of the fact that it's compiling and jumping into it's like what it compiles and stuff. Like just because it does that, it's going to be a lot harder for this to work there.
I don't think
But
it could work. Yeah, it would just
well,
cause too many problems, I
you
think.
would need some way to exclude certain areas or certain memory regions from being checked, and it would be able to protect those more static regions.
Yeah.
But that's where it comes down to, like, you can even just implement it behind something that's a bit more static, so the JIT area isn't protected and other areas are. But I mean, most software isn't doing that. Most software, this would be reasonably effective, I think.
Yeah, especially so I'll clarify a little bit for those listening. So by false positive, they basically mean by that something that was detected as like a, malicious gadget wasn't, and then by false negative they mean like it wasn't detected when it should have been. And like the false negative rate, while it's 0.6, it's a lot safer to have a false negative than it is to have a false positive. So like false positive's only 0.15. So that's just I can't believe it's that low, to be honest. Like it just seems really
I mean, I can because there's only so many places you're going to jump in proper code. I mean,
that's true.
the control flow graph is pretty static in most applications. Um, so as soon as you start doing ROPs, but at the same time, you can kind of look at doing more block oriented stuff then perhaps as a way around this, and it just is a general way around a lot of the control flow integrity checks. As what can you do by taking advantage of the entire block or the entire function so you're still jumping into proper places?
Yeah. So
Um,
that kind of reminds me of like, that magic gadget in libc where you could just jump to a function that'll launch a shell for you. Like functions like that, I'm assuming you mean?
um, not necessarily, but I mean, basically just code reuse, but doing so with the entire function. Like just that function maybe has a side effect of modifying some piece of memory that you can take advantage of.
Yeah. Yeah, I mean, honestly, I haven't really written exploits that bypass control flow integrity. I've never like systems I've exploited haven't had it.
Yeah, which is fair. I mean, you don't run into it yet too often. I mean,
Yeah.
clearly it's coming.
How long do you think it'll be until it's here for like for like most devices? I mean,
Well,
because obviously it
well,
won't be
for
that.
most devices, if we're including phones, if you're, I'd really say years. Like not that many years from now. 5.
Like within 5. Yeah.
Yeah,
Okay.
I would argue at least for phones, devices like that. Because it's going to take a little while for things to get adopted. Like in terms of it being introduced for the first time. I mean, does an iPhone actually do some integrity checking?
I'm not sure. iPhone does a lot of shit. They have a lot of mitigations. I
Yeah, it
wouldn't be
really wouldn't
surprised if they do.
surprise me.
Yeah, exactly. Um, but like it's just so some of the negative points of this paper. They basically said that on like when you update the code, you probably need to retrain it on the new software, and but it's just like yeah, I think that's the biggest negative. And like you said, you need to build that sample collection to do it.
Yeah,
But
there's that training time.
yeah, but do you think like this could be practically implemented as it is
Oh,
into like modern?
for sure. I think there are places that have a higher security standard are willing to invest that bit of time and could absolutely start putting this into practice like pretty much immediately. I don't think that's going to be a widespread thing, but those that really care about security, I think they absolutely could put this in, assuming they had a processor that worked that I don't know. I have to assume that this is on like the server end chips and stuff, but I don't actually know. I think they use a desktop chip
Oh, okay.
for this, but I'd have to assume that it's on the more enterprise level chipsets.
Okay.
And I'm just looking up here. Looks like there is control flow integrity actually being done on Android now already.
It's not out,
In
right?
the
Like it's
kernel, the Google Pixel 3 will be the first Android device to ship with forward edge control flow integrity.
oh, look at that. See, Android's really trying to push more on those mitigations. Um which
Yeah, I
actually
think we'll
makes me
be
wonder
talking a
if
bit about that later too, about some stuff
well,
coming in
we
with
had it after
you.
another link, but do you want to move that up actually? Just because it would kind of flow with it. Um
Yeah, I
but
mean, we could
yeah,
definitely talk about. We can jump to that next for sure.
yeah.
We can jump to it right now. I guess the last thing I just want to say is, yeah, I do think this one, not the Android one, can definitely be practical, can be used. Right now, there's still kind of the rough edges that only those that really want it are going to start applying something like this. And I mean, I still have questions about the real world accuracy rates, assuming those are okay. I mean, I
Yeah, so they gave a
would.
few. Like they have Flash, Nginx, Firefox, but they don't
Yeah,
have like a
but
huge selection. Like, yeah.
I guess my question would be more. Actually, first of all, Firefox, I mean, I have to assume some stuff's being JITted in that and in Flash. So, I mean, it's interesting
You would
because we were
think,
just talking
yeah.
about the JIT. So, I'd maybe want to dig into that. But,
And
uh,
interestingly, those had like the highest precision compared to Nginx and ProFTP.
which I don't think are doing the JIT. So,
Yeah,
yeah, I mean, that's
interesting.
definitely interesting. I mean, it is. I mean, the accuracy. If the accuracy is so good, great. But there's kind of the question of when they start running it on other people's machines. It could be a case of it works on my machine. Maybe it's not. I imagine it's not.
I didn't see
Um,
anything indicating if they tested on multiple machines or not, so that's actually a very good
they
point.
kind of have, the total data set there, which, it's a big number, but I don't really know what you'd expect with this either. So,
Yeah,
I don't know what they've done there. You would assume that it wouldn't totally matter. Like, you could probably train like just the Firefox build, especially for Windows users who aren't likely to be compiling their own Firefox. You could probably like take the training data and just apply it immediately. Like train
yeah,
once, but then everybody can use it, and that might be somewhat more practical too, because that way it's being assuming the training were done by developers as they release an application.
yeah. So, moving a little bit into the Android stuff, one thing I did want to talk about where you were saying that they're trying to push control flow integrity into Android is Android's been going kind of hard lately on trying to get more mitigations in their system. I remember reading a thread a little while back by some ARM devs, and they're trying to get pointer authentication in Android as well. They're having problems with it because the way they like spawn processes or whatever would cause a crash. Um, but they're trying to implement pack, and from what it sounds like they're trying to implement control flow integrity, and they also just put out this article on May 9th talking about a bunch of other stuff they're doing to try to mitigate Android exploits.
Yeah, so
um
just before you jump in quite to the mitigations, this report actually includes a lot of data on the types of issues they've seen, which I think
yeah,
is just interesting to see because obviously Google has a lot of insight into what issues they're having reported in Android. So it's just interesting to see kind of where issues are being reported, media and Bluetooth.
definitely. So I was actually a bit surprised that they actually had so many bugs in media. I thought media bugs were starting to die out, like like parsing bugs or anything like that. I thought those were like, well, maybe,
Yeah, but there's so many codecs, so and you can.
yeah. What I'm thinking of is it's probably harder to exploit these bugs, but there's probably more of them. So there's still vulnerabilities, but they're probably just not as exploitable, which they don't really touch on. I don't think they touch on the, how exploitable any of these vulnerabilities are.
Yeah, no, they
Um,
do talk. Well, I guess it's a link that they talk about how they triage the reports a little bit, but that isn't quite what you're talking about. But it touches like at least on a bit of a tangent.
yeah. So they were basically saying that like pretty much like most of the vulnerabilities by component, media was the biggest one. Next biggest one was Bluetooth, which is not a surprise. Bluetooth is crap. I think we talked about that on the last episode. And then the third most was kernel. And so I'm a little bit curious on this because I've noticed like Linux has Bluetooth stuff in the kernel. So when they say Bluetooth, I'm wondering if they're talking about like userland Bluetooth stuff or kernel Bluetooth stuff, since they have kernel as a separate category.
Yeah, I'm not sure if they really describe the difference or like how they're differentiating between that. I would assume though that they're including the kernel Bluetooth like module and like information. That they're including that as part of Bluetooth because they talk about
Probably.
um or actually do they? I know they mentioned a little bit with the media stuff and moving it out of. I guess that was just out of the monolithic service that they had, not necessarily out of the kernel. They obviously weren't doing that in the kernel. Um, yeah, my guess would be that Bluetooth kernel land is still included under Bluetooth, though.
Yeah, probably.
Um, could be wrong. I don't think they actually say. Like, they could definitely, like, it would be well within reason to have kernel stuff only include kernel and Bluetooth being userland.
Yeah.
Um, so pure
Uh,
speculation.
but one thing I did find interesting is Wi-Fi is like the smallest sliver outside of other, and you would think I thought Wi-Fi was like I've seen Wi-Fi be the target of quite a few attacks lately. Like I didn't think the code was that high quality in the Wi-Fi stack.
Yeah, I
So
mean, a
I'm
lot
I'm
of
interested in
Wi-Fi
that.
attacks though focus on like breaking the crypto of Wi-Fi, not so much exploiting the host system. I mean, no doubt some do, but trying to do that is a little. I guess Bluetooth is also like any radio is a bit of a pain to test with, but that's why I think media kind of gets hit on a lot. Bluetooth, you can get like Ubertooth and stuff that make it pretty easy. I'm not too sure about like testing frameworks for Wi-Fi though.
Yeah, that's a fair point. I never really. Yeah, that's fair. And it could just be too, like, there could be a lot of bugs in Wi-Fi. It's just not a lot of people are looking at it because it's harder to look at, like you're saying, than
the
some other
steps need to
components.
kind of get in there.
Yeah, exactly. So
but yeah, moving. No, go ahead.
Well, I was just gonna say, look at that. We're on the same track mind. Like, you know, moving on from the components, they also gave some description on the vulnerabilities. And the most common were out of bounds read and writes. So like probably I imagine a lot of them were like indexes into tables and stuff like that that weren't checked or whatever. And then the third most was use after free. So
yeah, and I mean I don't think anything there is really unexpected. Nothing really surprised me.
Well, I was a little bit surprised with how much more common out of bounds stuff was than UAF. I thought UAF was actually a bit more prevalent than this graph shows. So that kind of surprised me a little bit.
Yeah, no, I disagree, but I could see kind of why you maybe think UAF was more common. Because it's definitely something I see a little bit more, especially in like the kernel land stuff. I hear more about the UAF there than userland. I mean, obviously there's userland UAF. I'm not saying there isn't, but just in terms of the types of issues, I could see UAF being a little bit more prevalent in kernel. That said, you've done a lot more kernel than I have, so
it's just that, like, especially where you have like you can easily have multiple threads running in kernel, and an attacker can easily control multiple kernel threads. It's just like managing memory is like a million times harder. So that's why I was thinking there'd be more UAF than out of bounds stuff, because like checking indexes into tables and stuff like that. Well, you know, I obviously don't know exactly what all the issues were because they don't, you know, provide a detailed description of every vuln they've gotten. But like I just feel like out of bounds read and writes are easier to catch in code review potentially than use after freeze, just because use after freeze there's so many paths that you have to manage. Where with out of bounds stuff, it's a lot easier to catch.
But with use after freeze, they're also a lot harder to find. They're a lot harder to just catch that, as you're saying. So you have to have the vulnerabilities by cause. You also need to be able to write them. So
yeah.
But that said, I mean, the other thing with code, since you mentioned code review, is I mean, you could catch that in code review, but sometimes you make the assumption, oh, well, it's checked in this higher function, and you don't know all the paths into that function, or you don't necessarily know all the xrefs.
Especially with how many damn macros kernels use. Yeah.
So, I mean, that's another area where, you know, you can see those OOBs just being passed over. It's like, well, we only want to perform this check where it really matters. You don't want to have the performance hit of doing it every single, you know, if you have a macro, you're not going to want to necessarily perform that check every macro use. You might want to do it more generally, and then once it becomes trusted, not worry about it.
Yeah. So, you know, so like you were saying a bit earlier, one of the big things they did in Android Q was they moved their media services.
Well, so that happened with N. Sandbox. They're saying with N, and then Q, or they talk a bit through the process here. N did that, some re-architecting, and then Q, they then move the codecs out of, I guess, as codec processor service, and into a what they call, what was it, constrained sandbox, something like that.
Yeah, constrained sandbox.
Yeah, which, side note, I mean, SE Linux is a pretty solid. Are you familiar with SE Linux at all?
Like, I've looked into it a little bit, but I haven't really seen I haven't tried to attack it myself, but I've heard it's super good. Like the policies
so
and
stuff
it was. That it provides.
It's another thing coming out of the NSA. Just since we've talked about Ghidra before, you know, SE Linux is another, I would say, positive contribution from the NSA.
Okay.
But yeah, it basically just provides strong access control via policies that, get applied to the processes. So the process say, your Nginx server isn't allowed to access the database folder, like any of that. It's not. Like you're able to define things like that. You're able to define what files it can see and access, read or write or execute, in addition to just your normal operating system level stuff. It has these policies applied at a process level. A lot, it's intended to be a security thing, unlike just doing like a ch root, which if you get root, you can cd right out of your
Just straight
jail.
around it.
Yeah.
Yeah. The other interesting thing they did was they added more bounds checking in the Bluetooth stack. They like went through the code in the Bluetooth stuff and just added a bunch of bounds checks. At least that's how I understood it. Right. Incorrect.
So the bounds sanitizer and the integer sanitizer, the next section down, those are actually automated things. That's not, they didn't go through and add stuff. What they're doing is with LLVM, they're using that compiler level add-on basically, where if the size of the array is known at compile time, it'll automatically add bounds checking.
Yeah, you're right. Yeah, I messed that up. Sorry. I wasn't thinking. Yeah, you're right. They put it in the LLVM stack.
Yeah, and then the integer sanitizer, I think, is also in the LLVM stack. I don't see it mentioned there, so maybe I'm just mistaken on that. But essentially, I guess it must be because it's adding instrumentation around the arithmetic operation, so they abort when an overflow occurs.
Yeah.
And those are two pretty solid mitigations too. Like just adding those bounce checks, getting them in there, so often they are left out. And obviously you can't overflow your integers if it's going to come, or if it's going to abort when you overflow. You want to talk about the shadow stack?
Yeah, I was just going to say we were talking a little bit about CFI earlier, so they were actually saying here that LLVM CFI was added into the media frameworks and Bluetooth and Android Pie, which I actually didn't know before. I didn't realize that was there. So CFI is actually in Android already in some of those, I'm guessing, userland components. I don't think it's in the kernel. I don't think it is.
Yeah, I don't know.
But yeah, it mentions Q uses the shadow call stack to protect return addresses and stuff like that. So
yeah, so that actually makes me question, because the thing I just read about Android having CFI was also mentioning these forward edges of the call graph. So I think this is what it's actually referring to. Okay. Is this type of CFI. So okay, this is definitely a weaker sort of CFI.
Yeah.
Still absolutely an issue and all of that. But key thing here is it's not really it's only looking at your front, your return or whatever. It's only looking at where it's going right then. So kind of weaker than the control flow integrity that's that's looking more at the control flow chain to see if that's valid.
Yeah.
That said, this is still obviously a formidable issue, or formidable I guess opponent when you're doing exploit dev.
Yeah. The other thing that I found really interesting, which I haven't really seen before, is this execute only memory. So when you read that at first, when I read it at first, I was like, okay, we already kind of have that. Like, we can't have, like, you don't really have writable and executable memory.
Yeah, you're thinking
anymore.
of NX.
Yeah, but this actually makes it so you can't even read the executable data. So like trying to dump memory live or anything like that, you can't do, which I thought was like, wow. How does it, like, I'm actually curious how the hell that even works. Like, how do you make it executable and not readable? Like, that's just,
well,
I guess.
So the architecture, it's because these things are implemented at like the CPU level. It can know when it's having like a load or a store or whatever into that, but it can load whatever it wants. The CPU isn't bound by the same permission system. So if it's only execute, like, it can still fetch the instruction. It's just not fetching the instruction into, your register. And I think a lot of cases you have access to the binary.
Yeah.
So this, of course, like so many things, it's definitely a challenge, but if you already know what type pointer you're leaking, it's less of an issue, assuming you have the binary. So again, kind
Yeah,
of going
that's
with stuff
fair.
you've done, like on the PS4, a bit more of an issue if you can't dump the binary using it.
Oh, this would super suck on something like a PS4 where you're trying to dump the binaries. Yeah, this would be a huge issue. Which
Yeah, but I think
hopefully
it's
Sony
less of
isn't
an
listening.
issue. I think it's less of an issue on more like desktop applications or anything that you can kind of run for yourself.
Yeah, I mean, I guess the biggest thing that this would impact is like trying to brute force. If you just try to like guess a pointer and then read like
There,
dump the
yeah.
contents and read back to try to find gadgets or something like that live. This would kind of mess with that.
Yeah,
Um,
and I mean, this definitely would mess with a lot of things. Just you need to know exactly what you're leaking and what you've got. You can't just play around and try and figure it out or hope for the best.
yeah. This does kind of make me think, though. This isn't from the article or anything. Um, like if this type of like mitigation is possible in other cases, like if you could somehow make read-write memory not dump. No, you couldn't. Probably couldn't do that.
Well, if you need to be able to read it,
Yeah,
a read write is going to be obviously you can make
yeah.
it
I was
not
just trying to think of like
executable.
how you might be able to do
I
it,
think
but
in this
yeah,
case, the unique thing there is just the fact that it's taking that executable aspect and it's like you can't read it and just preventing the read.
yeah.
I mean,
I'm
I
kind of
think it's
surprised
just something
nobody's
that's
done it
been
before.
overlooked. Yeah. Yeah, I
Yeah,
agree. It is. It's weird that just nobody's really done that. Or maybe they have and never caught on. Maybe there's some other reason causing that. As you're scrolling there, though, the Escudo, I'm not sure how to say that, but their heap
Scudo.
allocator. Yeah.
Yeah,
It actually looks like it's got some good mitigations in there. I've never looked at this one, so I can't comment on anything really about, but like how the quarantine works to prevent UAFs. That said, it does do a couple things. It tracks chunk sizes chunk states to avoid double freeze. And there's a header checksum to prevent overflowing. So I wonder, is the header? Can you predict like how does the checksum work? And would overwriting the header, is it possible to overwrite the checksum? Because if the user can control, say, the entire block and the next checksum or whatever, that's obviously kind of a way around that. It's not preventing it necessarily. You obviously have to know a lot of information though in order to do that. And kind of similar with checking the chunk states, assuming that's also being stored in the header like it is with like PT malloc. Then you could overflow the header, write your own checksum, and violate the double free aspect. That's a lot of steps to kind of get in there on an exploit, but it's maybe
yeah.
something.
I'm just wondering, is this? I'm guessing this is a userland heap or allocator. Like, I don't think they replaced the Linux kernel
Yeah, no,
allocator.
I believe
Yeah.
this is our user land.
Okay. Yeah. So yeah, I didn't look too much at this either, to be quite honest. But it is interesting that it's hardened against, especially double freeze, because those can be extremely powerful bugs. So
Yeah, it really
trying
depends
to
on
kill
how
those.
they do that though, because there's a number of allocators that do some work against UAF, but it may be incomplete. They're like, I mean, there's what's that? It's not super recent. It's definitely been around for a few years, but there's a PT malloc issue, fast spin attacks. Like there is the UAF, like for the double free, there is that checking in there, but it's not in the fast spin. Does this have something like
Oh,
that where
definitely.
it's
And
it's
even, well, I was just gonna say, even where you have, so a lot of double free checks, they'll check if the last pointer that was freed is equal to the current pointer that's being freed, kind of thing. And even then, you still have issues because you can use like some races to try to fool that and get another pointer allocated in between, and like you can do a lot of like cool tricks to evade that. Which
yeah.
I'm
So
wondering
it
if
really
this
comes
is
down
weak
to
for
how
that
they
too.
do this.
Yeah, exactly.
Since they do say tracking chunk states, My guess is that, so like when I read that, my thought is that it's probably in the header just marking that it's free, something like that, or just marking it somewhere. Probably not a header, but
Maybe like a shadow
perhaps,
heap or something.
yeah, shadow heap. Or I was just thinking like a metadata store, basically, that tracks
Yeah.
that, which would be effective and wouldn't kind of have that same issue of only looking at the previous free.
Yeah. So moving a little bit like out of the more technical aspects, just to like a higher level view. I know Auntie's been kind of quiet. Are you still there, Auntie? You're still alive?
Yeah, man. No, I'm still alive. It's so in depth that it's better me to sit on the sidelines, let you guys hash it out. No, it's a good talk so far.
Yeah, no problem. No, I just wanted to ask you, like, do you think that this like how common are Android attacks as opposed to iOS attacks? Do you know? Like
I guess in
how much
terms of
like
malware, you're asking.
yeah, like in terms of like even like, APT attacks and stuff like that. Um how much more common are they on Android as opposed to iOS? Cuz iOS is leagues well, iOS seems to be leagues ahead of Android in terms of security. So I'm just wondering like if this may help in that regard.
Yeah, I mean, I think it's hard. I don't necessarily have any statistics, but from my understanding, like a lot of attacks against Android users are probably more common from um, nation states, right? Where iOS, I mean, you guys already talked about, is kind of a bit more locked down and has a lot of protections in place. Android, as we know, has so many different kind of like little distros by each carrier and other things like that that really open it up.
It's very
So
fragmented, yeah.
yeah, so it makes it hard to have consistent security. I know that from my understanding, Android O is supposed to fix a lot of these issues and kind of segment everything from each other, right? And I don't know if that's helped everything, but I do know that a lot of nation states, specifically in the Middle East, target Android users because there are companies that offer exploits and stuff for those types of phones. So I mean, that's just my anecdotal evidence. I don't actually monitor those types of campaigns as often, but you're going to definitely see that a lot less with iOS. And typically, you also just see less technical attacks, like again, phishing through mobile phones is a lot easier because there's a lot less protections in place. Is another one. So I don't know, if this would actually help anything. Sometimes it's just the user who's stupid, and you can't always put that in the kernel, to stop users from that.
You can't patch stupid.
You can't patch stupid, sadly.
Damn, that should be our tagline. That's amazing.
You can't patch stupid.
Yeah. Um yeah, overall I think, you know, I wouldn't say Android slacked on security. I'd say Android, at least compared to desktop, mobile is actually pretty good in a lot of areas to security. Android's biggest problem is probably like you were saying, that fragmentation of versions and stuff, like each vendor rolling out their own modified version of stuff, and just like that's probably their biggest issue. And that does kind of make me wonder if this, like some of these mitigations won't be shipped on some like certain phones.
I doubt it.
Like
I
just
imagine they all will be. I think Google's actually been pushing for there to be a faster response for the security updates. Like, the OEMs need to get those updates out within X months. I'm not sure what
yeah.
the numbers are, but I really don't think we're going to see just things not being implemented or being disabled for certain phones. They make their changes, but, this is core Android stuff.
Yeah.
Where like they'll make changes on top of Android. A lot less is actually modifying core Android itself, as far as I know.
Yeah.
And I imagine Google just wouldn't let them to some extent. Like Google definitely, like I said, I don't think they've slacked. I think iOS has just really been on top of things in that sense. I don't think Google's been slacking at all with Android. And desktop,
No.
desktop just has the greater challenge also of arbitrary programs are allowed to run.
Yeah, mobile can have more restrictive environments without
Yeah.
like sacrificing too much functionality. Yeah. Yeah, I mean this is these actually do seem like some pretty significant changes. A lot of it seems to be focused around attack surface reduction, which SE Linux already does pretty well, and it's just doing it even further. Like that is one area that mobile in all areas seems to have locked down, is attack surface reduction seems to be pretty damn good, like the sandboxing and stuff like that. So yeah, it'll be interesting to see how much that affects any like future attacks against Android. So I guess we'll jump back to the
topic we kind of
the
skipped
other.
over here. This relying on strong types for security. So
Yeah.
this paper, first of all, I just want to mention the terrible formatting of
That's
this.
so bad.
Like, I mean, just this very first page, like, how many fonts are there? 1, 2, 3, 4, 5, 6. Like 6, 7 fonts on the first page here.
It's
Maybe,
also
maybe I
like the
miscounted
main.
stuff, but sorry, go ahead.
I was just gonna say it's also like the main font seems to be that weird, like taller, more compressed text, which I
Is
hate
there a
reading.
main font? Really?
Good
What
question.
the hell is that? What
I
is
honestly
going on?
had a
I've
hard
never-
time reading this paper. Like, legitimately, the bold italic stuff, I think it was. Like, these things are just, it's hard to read so much of this.
Dude, this was written by someone with like who only uses Linux stuff, right? And they're like, they had to like made this through the terminal, so they have all this weird
Well,
stuff.
this
They
is
can't use
latex,
titles or something.
obviously.
It's terrible, man. I've never seen someone use so many different fonts.
They even have like cursive writing.
Yeah, I love that in some of the code. Obviously, completely unrelated to the topic of this, which is the idea of strong. So when I saw this, I thought it was going to be an argument. Like when I saw the title, I thought it was going to be an argument towards using programming languages with strong types. And I mean,
That's
it
what I
kind of
figured, too.
is. And maybe we'll touch on that. But the other thing of what it's kind of going for here is essentially your strong types, like your primitive, like they're talking about mathematically strong types. So things you can reason about, you can have axioms and turn your entire program. Like essentially, this ends up boiling down to having formally verified software and making that, or writing formally verified software, which isn't a new idea by any means. But they just kind of make like the argument that the current poor cybersecurity that we have means that we should shift to this mathematically strong typing. And I'm going to say, like, I agree to the extent like we currently have pretty poor security, and I think a lot of security issues, especially when we're talking about the higher level issues that are a bit more prevalent than the binary issues that we were just talking about. I mean, using a statically typed language, even if it's not necessarily strong, but just statically typed, solves a ton of issues just with type coercion. So, like, the typing, like, they're not wrong, but going all the way down the deep end to formally verify, as it stands, like, being able to formally verify your software, being able to formally prove that, yes, it does what it's supposed to do and it doesn't do anything else. So it doesn't have any overflows, it doesn't have any ways to hijack flow, like, it only does what it's supposed to. Proving your software would be completely useful. It's just so impractical to write that usually involves writing everything twice. You write the code and then you write the formal proof of the code by looking at your old code, or you go the other way, write the proof, write the code that matches that. It's just not practical for actual engineering, actual development of software. And I mean, sure, this guy's wanting to say, yeah, let's, use these types and let's do that, but without proposing, I think, a good language that makes this easy, that makes this practical for an engineer to do, it's just never going to catch on. And I think it just goes too far down the one side. I think, we're going to have a middle ground before we actually see all programs being provably secure.
Yeah, I mean, it's just like I feel like Rust kind of tries to do that, doesn't it? It tries to go strong, like tried to prove the types better. Like I think if you wanna get less strict with the types, you have to use the unsafe keyword or something like that, right? I haven't done too much with Rust, so I'm just trying to think if like
Yeah, so Rust,
I'm on the right track.
I mean, Rust definitely has that unsafe keyword that you can then do pretty much whatever you want.
Yeah. I'm just wondering if it has kind of that stronger type system that this paper is trying to propose.
Not
'Cause I have heard-
mathematically. It's not.
Not okay.
as far as I'm aware, Rust wouldn't necessarily let you build kind of these I mean, it's a little bit better, I think, than like Java with its inheritance system. I think the composition system of Rust is a little bit closer. To be fair, though, like this definitely is like this brings back memories of discrete math in university. It's not something that I've really cared about since then. So
Yeah,
if
I
I were
never
being
took that, so
honest, it's yeah, like if I'm being honest, like I haven't done program pros. Like this is not any sort of area that I'm really an authority on. It's just uh, I just feel like it's trying to push us way too far down that one side. It's maybe not wrong in the theory that doing that's more secure, but there are more practical options.
yeah. I mean, yeah, it does get super mathematical. Like there's a bunch of symbols in here that I don't even know what they mean. And then you mix that with like the cursive and it's just like this is not a fun statement to read, honestly. Um I guess you can like you probably understand it a lot better than I do just because you were just saying how you took like those math courses and stuff. I haven't obviously. So um I mean, yeah, I didn't read the paper too much, but I feel like I'm probably on the same ground as you, where it's too theoretical to work in practice, especially when you're talking about like engineering and stuff like that, and how
Yeah,
things have worked for so long. It
like
just doesn't seem like something that's going to happen.
yeah, I mean this kind of the whole idea of having these formally proven software like that has been I'm going to say like a pipe dream in both mathematics and computer science for a while to be able to do that. And I mean, there have been movements towards making that easier, making that a bit more doable. But at this point, and I mean, this could be a next step towards that. I don't necessarily think it is, but I don't know who's going to run with this idea next, or maybe this paper. I mean, this at least seems a little bit higher level to be something that somebody else could build on. This is more about how we should be relying on it rather than like introducing some new concept. But yeah, I mean the whole idea it needs to be made more practical.
Okay, yeah, I think I'm pretty much on the same ground. So we'll move on to some security practices. So
An
I
attack.
remember, or yeah, an attack. I remember. So we were kind of like on the fence about if we were going to talk about this or not. Just because it like
I mean, part of it's just kind of like, of course, yes, application can listen, see its own or see when it's running, determine its own run intervals. When it's not running, something else is running.
yeah, so for those of you listening and can't see the screen, the paper is a novel side channel in real-time schedulers. So from what I gathered about it, it was talking about using timing attacks against the scheduler to try to figure out when certain tasks are running and stuff like that.
Yeah, the idea
Um,
being like certain regular tasks that come in. It wasn't
yeah,
just like when random program X is running, it's when is, this regular task actually being executed.
yeah. And the paper focuses on embedded systems, so like, car like auto-driving cars,
Yeah, which is
UAVs,
where you're going to
stuff like
see
that.
these real time schedulers.
Yeah.
I mean, you're not really seeing that on your desktop system. You're seeing that on these really lightweight things that are only running one thing at a time for the most part.
Yeah. So I guess my biggest like issue with it is, to be able to pull off an attack like this, you already need that footing to be able to get a precise level of observation. Like you already need that like entry point in there. And my issue with that is like that seems obvious, but my issue with that is they're talking about using this kind of attacks against like military stuff like NASA rovers and stuff like that. And they're talking about the opportunity to either steal a critical piece of information can be very limited, but this attack seems even more limited than like other attacks you could use, if that
Yeah,
makes
I
sense.
mean, well, I guess it's the foundation you need is really limited. You need to be running your own program. So that is you've already compromised the vehicle. You know, if you're going to go against an autonomous vehicle, you need to have already compromised it. And you're
Exactly.
going to be able to
Like,
pull more information out. But I mean, a lot of things are like that. You know, you still secure your admin areas of like a web application, even though most users are never going to get access to it. It's just kind of those layers of defense.
yeah. But then you also have to chain that, like, that high level of access you already need. And then they even stated in the paper that this attack is not trivial to pull off. Like, extracting this information is quite a task and can be uh, very different depending on each system. Like, I'm just trying to find where they.
Yeah, well, I mean, most timing attacks really are not trivial.
Yeah, it heavily depends on the state of the system at startup, initialization variables, environmental conditions. I mean, like,
This
it
takes a
just
ton
seems.
of inside knowledge.
Yeah, like, it just. I don't know. I just guess I don't really see too much of the point of this paper. Because I mentioned a little bit before we started, it says it's a novel side channel. The only thing that's novel about it is, I guess, attacking like this area, but like timing attacks are nothing new. And like
Yeah, I mean,
given
it's in particular just, I think, calling out the fact that there is a side channel in the schedule, in the fact that, you know, it's being scheduled and all of that. That's what's novel. It's not the timing attack that's new. It's just the fact that it's in the scheduler.
but like what do you expect them to do? Like how do you like it just seems obvious like you were saying at the beginning, like how do you prevent that from happening? Like you're obviously going to be able to observe when things are running and when they're not. So like what do you really do to prevent against that? You know what like I just don't really see the point of the paper, I guess.
I mean, I guess the point is to point out that it's there. I mean, I'm assuming they don't talk much about, you know, a better scheduler.
Yeah, it just
Yeah.
seems weird. Like
So, I mean,
that's gonna
changing the
happen in any.
scheduler could prevent some of that. Well, it can make it a lot more difficult to pull information out. I mean, but that's also why this in particular gains real time schedulers and um not necessarily everything else.
Yeah,
But no, I agree. Like that's why I had initially suggested not to even bother talking about this because it's not like I don't think it's that interesting. 'Cause, I mean, it is essentially as I kind of summarized early on was yeah, something's running when you're not. You can determine that.
yeah. So we did just want to bring that up, just because you know the paper was released. It's just yeah, it's just weird, I guess.
Yeah, I mean
Um,
it's absolutely a fair thing. And sorry, there's always a chance that in the future somebody's going to see this and be like, "That is exactly what we need to pull off this greater attack," and we're just not seeing it.
yeah,
I mean, maybe we're just lacking the creativity to see that or domain knowledge. Like there's definitely a chance somebody can build off this. It is a legitimate thing. Like it is a legitimate side channel.
yeah,
On its own, this doesn't seem all that useful, and I think they kind of even point to that. But who knows where somebody else is going to take that in like 5 years? Maybe they'll actually have something a bit more, not necessarily more practical, but an actual use case where it was pulled off or actually used.
yeah. Now this has nothing to do with the paper. It's just something I just noticed in the credits here. I thought this looks funny. Like they have students from Illinois, Waterloo, so Canada, and Oregon State working together on this paper. It's what the hell? Is that a common thing in university for like ones that like three universities that are like completely different countries to work together on this
For
kind of stuff?
actual for actual research, I don't believe it really would be because usually the research team is all kind of together.
Yeah, it
That
just
said,
seemed
this could
weird.
have been something like they all started together in Illinois, and then those two people, kind of over however long this took, left to another university.
Yeah, it's
Like
just
it
it
could have
seemed
just been
weird.
they
It's like
left. It's
not
just
even close
since
to
they
together.
are because usually the order is based on importance in terms of like what they actually did on the paper. Those are also the last two names that are from somewhere else, so that could be related, or it could be misremembering the importance of the order.
Oh, okay, okay. So I guess we'll move on to MAVSec. So securing the MAVLink protocol for basically UAVs.
Yeah, particularly like PX4 and RG Pilot are in particular kind of what's using this. Um, we don't need to talk too much about the whole paper itself. It's not that interesting. This could be summed up as implement cryptography over the plaintext protocol. Is effectively this whole thing just talks about, and one thing it makes like the whole thing's just talking about encryption and comparing different encryption options. I'm actually
Yeah.
kind of disappointed that I didn't spend too much time looking at what security was actually needed for this. Do you need confidentiality when you're talking about the controls to a visible device? You give it, command to go off, like it goes up. It's a visible thing also. Is confidentiality the biggest issue? Because they're also comparing this with performance. Could you get away with integrity? Just having like an HMAC. Could that, because that would solve a ton of the issues. Injection, wouldn't really solve man in the middle, but you couldn't tamper with it. It wouldn't solve the confidentiality aspect, but everything under integrity would be, or could potentially, maybe not message deletion actually, depending on how you kind of implemented that HMAC. But like little things like that, I just didn't approach that. It's just, you need to implement crypto over this.
Yeah, that's what I mainly saw in it. It was like they talked about how basically MAVLink has no authentication mechanisms, no encryption. So you could, it was vulnerable to all types of attacks in CIA, confidentiality, integrity, and availability. But they only really focus on the encryption aspect. Like they don't even really talk about the authentication, if I remember right. Like I don't remember seeing much about that in there either.
No, I mean the whole thing was, just encrypted, and that makes everything better. And I mean, encryption does solve a lot of the issues. And just as a bit of a tangent, they make the comment symmetric encryption is fast by design and consumes little energy because the same key is used for both encryption and decryption. This makes it suitable for low resource drones, and that's why they didn't look at any asymmetric crypto systems. And I'm just going to say symmetric encryption algorithms, yes. Like the fastest one is faster than the fastest asymmetric system, as far as I'm aware. Like I'm thinking RSA and AES, so put that out. But it's not necessarily by design. You've got things like Bluetooth, which are actually slow by design, or not Bluetooth. Oh, why can't I think of the name of it now? Blowfish. That's one thing.
Oh, Blowfish. Okay.
Which is, slow, pretty much by design.
Yeah.
And that's symmetric. So, oh no, just little things like that in this paper. Like, it felt like they dove into a lot of the wrong details, and there was a lot of potential for what they could
dove
have
into
brought
which?
up
Sorry,
here.
you just kind of cut out there. For me.
It seemed like they dove into a lot of. I guess they went into the weeds, a lot of these little details, but didn't look at many big picture, like many other options. It's just crypto, just different crypto options. Ultimately, they settle on like you should use Cha-Cha 20.
Yeah, so I did actually find that interesting because they did have a graph here comparing the overhead of each encryption algorithm, and so they had like AES, CTR, CBC, and then they had RC4 and Cha-Cha 20. I'm not sure what RC4 is. I haven't really heard of that
Well,
before, I guess.
ARC4, alleged RC4. Technically, we don't have RC4. Only the alleged
okay.
version of it, but it's
Okay.
a stream cipher. So, like, whereas these other options will have encrypted blocks, you'll have
Okay.
your block size that gets decrypted. It's just able to kind of work each bit at a time. It basically just generates like a long key in a sense. It just kind of keeps generating a new key as it goes that it can XOR data with.
Yeah. I did find it interesting how there's basically negligible overhead with Cha-Cha 20 as compared to like no encryption at all. Like that's even the other two, like CTR and CBC, don't seem too much higher, but they are noticeable. But like our Cha-Cha 20 and no encryption are like almost equal. Like, what is it about? I don't know if you know this or anything.
So
I'm
I'm
just kind of
actually
throwing it out
not
there.
all that familiar with Salsa 20 or Cha-Cha 20.
Okay,
They're
so that's fine then.
related. I know they're related. I couldn't even tell you the difference between Salsa and Cha-Cha. So I
Okay, it
think
was just a personal curiosity.
I
It's
think
okay.
both are really just based on like some type of XOR op. Well, I mean XOR is kind of the foundation of like AS2, but um I think they're both really simple algorithms though.
Okay. Okay. Yeah, so we can talk about some smart contract stuff.
Yeah, I mean
So
again,
domain specific code smells.
don't need to jump into everything about this because there's a pretty big number of code smells that they mentioned in here.
I think yeah, they identified 16, I think.
16? I thought they had more than that.
It
But they had 7 that were
yeah.
security related.
Yeah.
And that's where I thought maybe we can. But yeah, because here's 20.
Oh, 20. Yeah, okay. Well, I thought what was the most interesting about it is some of them kind of overlap, I guess, with code smells that you have in other areas. But
That's what I thought too. Like it was interesting just how many of these really related to normal code smells. Like not just smart contract.
the ones that I thought were kind of interesting though were the ones that were specific to so basically like smart contracts like Ethereum and stuff like that, they have this gas system, so it costs like a fee to send it over the blockchain or whatever it is. I don't entirely understand it. It's a bit weird.
Yeah,
But
well, I mean, essentially think of it as you're paying for execution time.
yeah. So these code like a lot like some of the code smells that they have here are basically related to that. So like nested calls, for some reason public functions use more gas than like private functions. So basically stuff that would cause the contract to consume more gas than I guess it should by increasing that
Yeah, a
execution
few of
time.
the security ones related to that. The one that I'm kind of thinking of, and I think you had in mind too, is when you get an an exception in a loop. So when you kind of switch from kind of just performing the contract to hitting that exception, it tries to roll everything back. When it's in that loop, it's going to try to roll back all of the things that it did. And if it's user data in a loop that's causing this exception, they can kind of control how deep it is in the loop and things like that, so that it can run out of gas before it actually undoes everything.
Yeah.
But a few of these are also just pointing out certain things that people would depend on without actually, or trust, I should say, that code would trust as being is not necessarily being malicious. So trusting things like the transaction state, and from that transaction state, things like the origin is actually user controlled or minor. It's the block info. Sorry, that's minor controlled, but that's controlled. So it's not necessarily legit. I mean, most users are going to provide the actual origin, but you can technically provide any origin that you want in there. Similarly, the miner can control some piece of data. So part of it's just pointing out like trusting transactions, say, in block info, as things to be aware of as being a code smell, just trusting those areas rather than figuring it out or using something else. And then I thought it was interesting to mention the strict balance equality was one of the code smells where you expect the transaction to have a specific value, not just like equal to and greater than, but equal to some value. So you can forcibly send money to contracts or send Ethereum to the contract in a way that it won't be sent back to you if the contract fails. I think it's like a self-destruct thing, so you can get to skip out on whatever check if it's always expecting people to just send it like 1 ETH every time, and then when it has 10 it does something. You can just get to skip things like that. Like, I don't know, it was an interesting read, especially because I have not done any assessments on smart contracts, But a lot of these things, like I could still go and understand it just by looking at this paper. It lays them out pretty well. And I'm specifically talking about a lot of the security related code smells.
Yeah, I mean, I said it before. I do kind of want to look at smart contracts just because it does seem like such an interesting area with some unique issues that you could find, like this gas system stuff. You won't really find those kinds of issues in any other system, or not that I can think of. Um, I must say though, there was one code smell, or at least one that I felt was kind of odd to consider it a code smell, and it was the highest amount, which was the unspecified compiler version. I'm just not really sure why that's like a massive issue. Maybe,
Can you bring it up in the paper? I only focused on those security ones.
yeah. So they had it right here, the unspecified compiler version, and in some data sets they provided, it was the most common one they found. But I'm trying to find the quality of the rabbit on my screen is not great. It's not even loading for me, so I can't see it. But like I'm not really sure why that's a massive issue. Unspecified compiler version. Maybe it's a contract specific thing.
Well, so to be clear, these are code smells, not code issues. So they're just issues that are like, these are places where you can look if you're looking for issues. Like, this is something that doesn't quite seem right. I was hoping you could find somewhere that actually talked about it, like the security ones I was mentioning on the pages.
It was on the first few, I think. Yeah.
Yeah, kind of right up there. They've actually got, listed the security smell, and then they've got, unchecked external calls, and they have a description over why it's an issue. I was hoping to see something like that for this one that you're asking about, the compiler version.
Well, especially since it's the most common one they found, you would think they would like. Yeah,
Well,
I kind
so
of
they
misspoke.
don't. I'm assuming.
I didn't find any.
Okay.
Like, I mean, yeah, I kind of misspoke there. I didn't mean it would be an issue, but I mean, like, why would a unspecified compiler version even potentially indicate issues?
Well,
And
because
yeah, they don't
different
really.
compilers have different features, may behave differently.
Yeah, I don't know. I would have liked if they laid that out, especially since it was the most common one they found. But that's just like a personal thing, like a personal gripe, I guess.
Since you mentioned it, like, yeah, I'd like to know more about what they thought about it. But again, it isn't under their security smells. When I went through this, I was only really looking at the security smells area, like those 7 that they list here, because that's obviously what kind of interests us with this program are the security issues.
Yeah. So I mean, overall, I think it was actually. I think it's a pretty good introduction into smart contract, like code smells, which is basically what the paper sets out to do. So I think I actually really like this paper just because it's a lot more accessible than some of the other ones we've read.
Yeah, definitely. Like this, it lays things out pretty well. I think, their intended target doesn't necessarily know everything about it. That's what they're pointing out. Here are some of the domain specific code spells.
Yeah, so if you're looking to get into smart contract stuff, I feel like this is like probably a necessary resource or one of the top recommended resources for looking into it. And I might actually use this for if I when I want to look into smart contract stuff. So yeah, overall I really like the paper just because it's it's an overall study. It's not groundbreaking, but it's a really good introduction into that area.
Yeah, it's all the right information to have there.
Yeah. So let's talk about some MongoDB unsecured databases.
Yeah, so this is definitely, I guess what they say here, huge MongoDB database exposing 275 million, or more than 275 million records of Indian citizens. It was just kind of sitting there, living on the internet unprotected.
Of course, and they found it using Shodan, so
yeah, and it's it's an interesting one. So this is actually a somewhat common issue, just exposed MongoDB, because MongoDB by default doesn't do any authentication. It also only listens on localhost. But unlike, MySQL or something where it might only list on localhost, you still have to authenticate to it. Mongo is just really quick, run it, and just start querying it or inserting to it.
So as soon as it's made publicly accessible, it's basically game over. Sounds
yeah,
great.
I mean, so they absolutely do support authentication.
Okay.
But you have to enable it. It's not there by default. And that's why, like, anytime somebody does just move it to listening on the network, it suddenly becomes a big issue because so many people just forget to add authentication if they're going to do that.
Yeah. So I'm just wondering, Auntie, did you hear anything about this, or did you manage to read into this at all?
I mean, I'm sure I did at some point. It's hard nowadays because there's so many freaking articles that come out about unprotected MongoDB stuff nowadays. But I am actually, I do know about this one. The 275 million, what was the type of data in it? Was this
It was
the.
resumes of Indian users for the most part. It looked like it was part of a scraping campaign. So this wasn't like a company exposing their user data. This seemed to be like somebody that was scraping, or some company that was scraping this information and just kind of had it exposed, probably so all their scraping servers could update it.
Well,
Yeah. So
go ahead.
So I was just gonna add there, basically the information they got like name, location, job, skills, email, gender, phone, stuff like that is the main things.
Yeah, I mean, this sounds like someone that was probably setting up pages that go and help promote your resume or some bullshit, and then people obviously uploaded their resumes, and like I'm seeing a lot of people nowadays setting up like poorly secured MongoDBs because their whole scheme is going and collecting information like this, and it's usually tricking people by looking like legitimate websites, like, hey, you're looking for a job, upload your resume, or it even goes into a whole bunch of other little territories. So, but I am familiar with this one. I actually am kind of familiar with the researcher. He does a lot of this type of stuff. Um, you know, this is every time we've talked about it, though. This is realistically nothing new, sadly, and because how easy it is to set up MongoDB, I think it's just going to become a reoccurring theme.
Yeah, I don't know. I mean, like, I agree, assuming MongoDB actually kind of becomes more popular, but I think Mongo has kind of been on the down for the last little while. I mean, like,
Sort of, yeah.
that said, like, it is, as I mentioned early on, like, it's such an easy thing to accidentally do.
Yeah, I mean, it's in a lot of tutorials I see lately. And that's why I was kind of curious because, like, I know a lot of data scientists, I think, are using it, or is it? I know there's like some type of stack that involves Mongo that made it kind of popular, which might be like I think it was Node.js. A lot of people use Mongo with it,
Yeah,
so.
well, because Mongo is like a JSON store, pretty much. Like, all
Mhm.
the documents are JSON.
So that's the only reason I think I've seen a lot of it is because a lot more like people using Node and kind of seeing a lot of tutorials out on it. Like I think a lot of people are just using it because it's easy to set up. Kind of like the how it used to be like PHP and MySQL. People would go and set up crappy web pages and stuff
Lamp
all the time.
stacks, yeah.
Yeah,
Yeah,
so that was the LAMP stack, and Mongo's part of, I think it's the mean stack.
like something like
Like Mongo
Mongo. Oh,
Express,
yeah,
whatever
Angular or
else.
something like that, and Node. Or,
Yeah, Mongo Express, Angular, and Node. I just
yeah,
pulled it up here.
It's a
But yeah,
mouthful.
so like Mongo's
Um,
definitely, like, it's definitely used, but I think its popularity has been waning. Maybe I'd have to look up some statistics. I saw it mostly like, really 2 years ago, absolutely. But I think like this last year, I've been seeing a lot more, I guess, just hate and general distaste towards Mongo than I have in past years. That's why I'm kind of saying I think it's on the way out, or maybe not out. Actually, I don't think it's going to be out anytime soon. Like, it's
but
still going to be around, but yeah, it's by
yeah. I
default.
mean,
There's no protection.
and it doesn't help to be honest with you, dude. People are using a lot of stuff like Shodan and all that to scan for them 24/7. So, I think it's also gotten kind of that where people now are scanning the internet for people setting these types of things up. Because MySQL, I've been a hot minute since I've had to install it myself, but it does prompt you to set a password, I believe, but it doesn't automatically
yep,
connect out to the internet. Yeah.
yep, it does. It when you go to set it up, it basically has like a big red screen that says, "Please set a password." You can skip it, but please don't.
Yeah, like I
Yeah.
assume that it gives, from what I remember, the whole setup. It didn't force me, but it was like, hey, set a password. And so I think that
Well,
was
even
kind
if
of
you
the
don't, I think it just lets you use like a blank password. There's still some authentication to it. Like
Yeah.
you're very intentionally setting a blank password, like root and blank or whatever. Whereas with Mongo, its default is no authentication, not no password, no authentication. There's no username either. It's just connect.
Yeah, no, and that's a good point. Is
And again, there is authentication that can be enabled. It is there. I just think, like for Mongo, it really should be default for it to be there, even though it is listening on localhost. The overhead just isn't all that much for doing. In most cases, the overhead of authentication is a lot less than the cost of a compromise.
Yeah, no, and that's the problem though, is I just don't think most times it's just people don't really understand that it's out there or that happened. They just go, oh, I'm going to connect to it real quick, because again, not every person thinks like cybersecurity. They just think, hey, I want to set up my app to go and get people's resumes for a few minutes, and then they come back like, oh god.
Yeah, that's why it's nice to have the reminder when you're setting it up, like the secure defaults, because so many people are going to leave the default on.
Yeah, no, that should be something they put into the process, is enforce default security, and you have to go and manually disable those. People will still do it, but
yeah, but at least then it's them doing it, not their inaction that's causing security issues.
Yeah.
Now, to be fair, maybe Mongo does warn if it goes out to the network by default or something like that. I'm not intimately familiar with setting up Mongo. I've only used it on one project.
Yeah, I'm not entirely sure either. But with the amount of people doing it, I would be very curious as to what they do to kind of fix this. But I guess it's only fair to go
to fix it, it's enable authentication. Like it is, that's there. I know enough about it to say that is something that can just be enabled. Or, you don't listen on the network.
But I mean, has Mongo, the people behind the project, ever stated like anything about this shit? Where they're like, oops, yeah, we really
they have security recommendations. They have recommendations for how you should set it up and how you can secure it.
Because that's maybe, I don't know. I don't know what the solution is, dude. Like we talked about earlier, maybe sometimes you just can't patch stupid, and if it wasn't hurting other people, I wouldn't really care. But the bad part is it seems to be exposing obviously hundreds of millions of people. So those are painful lessons for other people as well.
Yeah, so I actually just looked up, and right in their documents, like they actually do in their documentation, they do have like a security and like a security checklist that includes stuff like that. That includes how to do the authentication, like they provide the auth features. They have a security checklist. Like I mean, besides it not being default, besides the fact that you actually have to enable that access control and authentication, like otherwise, like they have the feature there. It's there. It's okay. I just think it really should be a secure default, not taking an action to make it secure, or not requiring that action to make it secure.
Yeah, no, it seems unnecessary.
Yeah, I mean, what I was going to bring up was a little bit earlier. You mentioned that that people are scanning the internet using Shodan for this kind of stuff, and I've been seeing Shodan used in a few attacks lately, and I'm starting to wonder, like, if Shodan should start to be locked out to, like, people who are verified to be using it for good causes.
I mean, you can just use mass scan. I don't think it really matters the fact that Shodan makes it a little bit easier. You can scan yourself too. Mass scan is practical. You get a server, run mass scan, scan the entire internet.
Yeah,
they do have their own special configurations, to be fair to. I know that it's not just a straight up mass scan on a VPS. They do have a lot of different like extra scripts.
For sure. I mean, like Shodan provides a lot. I just mean, as an individual user, if you lost access to Shodan, it's not the end of the world by any means. How to scan the internet is kind of not necessarily a common knowledge thing, but it's out there already.
Right.
So, but Shodan does make it a lot more accessible. Like, I'm just wondering, like, with Shodan, it seems very easy to get a lot of information that, like...
Yeah, but I don't think the solution's preventing people to access it. I don't
Yeah.
think censoring the information is the solution. The solution is be secure. Don't run your stuff on the internet, or don't have an obvious banner. Don't have proper code. Don't have your IoT device just have hard coded passwords and all those other things, all those common issues. Like, I mean, all the information that you're seeing on Shodan can be found on your own too. So censoring
Yeah.
it, I don't think is the solution.
Okay. I mean, ideally, you're right. Yeah, there shouldn't be insecure devices or whatever. But it's just I don't in the real world, I don't think that's going to happen. I think there's always going to be shitty defaults and stuff like that. So it's just
Well,
I
until
just
that becomes
wonder,
a crime, then we might see less of it. But I don't know. I don't think censorship is the right way to go about it. Like, preventing people from accessing information. Like, should we prevent people from accessing our podcast because we talk about how to get around some mitigations at times?
I mean, that's a fair point. Like, it just I don't know. I'm seeing it used more and more recently, and like Auntie was saying, it's not like it's just compromising one thing. This compromised like a lot of people, like that. Unsuspecting people. So that's why I was just I was kind of just playing devil's advocate. Like, I don't really think we should censor that information, but I can see an argument being made for it, I guess.
Yeah, I mean, there's absolutely an argument for hiding pretty much any type of information that can be used to damage, but I think security grows by having that information accessible. By knowing that it's there, then people are more aware of the security implications. In this particular case, though, like, this looks like it's not a legitimate company or like that collected the resumes. They just collected resumes or scraped them, given kind of speaking of the naming sources or the naming scheme here, like the big 2 million whatever collection is named mediafire _csv _last _final. Just like the naming scheme on some of these things is kind of fine. Like, this doesn't come across as any sort of reputable company. This is just somebody that, likely, as they reason in the report here, probably was scraping this information out, and then successful. Like, I don't even think the Mongo issue is really the issue here. I mean, the Mongo issue is an issue, I think, with Mongo and all of that, but at the same time, this information being collected, I don't think it really has to do with Mongo being exposed. This isn't like some, for India, like their government was running this database and accidentally had it exposed. It's not even like that. It's from something else. We don't really know what, but something else. Although it's worth noting that the whole database itself was dropped by some hackers known as the Unistellar group.
Unistellar. Look at that. More creative names.
Yeah, so they dropped it and kind of replaced it with this, restore ? Contact in their email. And I think that's just speaking to, the whole script kiddie aspect. People searching Shodan, seeing that, dropping the database. Just somebody else found it and dropped it.
No, that's what happens a lot, to be honest with you. That's why I would say, to a little bit of a degree, it would be good doing the know your customer stuff, not letting script kiddies use these things, because they're script kiddies. They may not really know how to configure Masscan, but they know how to use Shodan, and Shodan kind of abstracts your IP, right? So if I go and run Masscan from my own machine, there's a chance like you're going to be caught faster than you realize.
Yeah, that's a fair point, actually.
But I do know that if I had to guess, to be honest with you too, is given the service of Shodan, I have no doubt the owners are very aware of what it's used for, right? On many occasions. So it's entirely possible that, like, they work with law enforcement, my guess is, and that all those searches people do put in, I have no doubt that they're looking at them and trying to see what other people are searching,
Yeah, do they take, like, Bitcoin, or, like, what's the payment system like for that? Like, do they offer some, like, anonymous thing that might obscure your identity, or is it generally people actually, paying?
I mean, that's a good question.
I guess there is the free thing too, but I'm assuming a lot of people aren't using the free, just like 50 results or whatever. Maybe.
I mean, I think Shodan accepts Bitcoin. To be fair, I do remember that being a thing. So I'm pretty sure they do. It's my understanding though with Bitcoin, when you take it as a business, you still have to do the know your customer laws. So technically, they have to collect some type of info off you. But I mean, that's a good point. I don't know if you can, if it's just like your name and maybe your number or something, but then
Yeah,
you
but
can
then they,
falsify
like
it.
verifying, yeah.
Yeah, I don't know how much actually they go to verify. That's a good point. So that's the other hard part is just,
Well,
you
I
know,
mean, I know you definitely can get on without a ton of verification, just because I'm on there without having paid, just through their like invite token.
mhm.
So like I was able to get on there without much of an issue or without any real verification that I remember. But obviously, the person who gave me that invite token knows who I am.
Sure. Yeah. I mean, but that's the whole reseller idea. It's supposed to help bolster privacy or anonymity a bit. Um, I think that, I mean, the long story short is, to be fair, there's still other services too, like Sensi's and stuff like that, that do the same thing as Shodan. So the other bad part is it's not like, just banning one. I mean, it really does just take a proactive approach of people improving their security posture and not relying on, we just ban the bad guys, so don't worry now. It only takes them getting banned to finally go and say, okay, well, I'm just going to look up how to use mass scan. So I think both sides, to be honest with you, are perfectly valid. I am just tired of reading MongoDB stories, for goodness sake. This is so, it really shouldn't be this complicated.
Yeah, I mean, I think like just in terms of that and not being complicated, I think if Mongo just had the default being with authentication, it would close up so many of these, because I think the core of it is just people exposing to the network their default and so.
hmm No, I think so too. I mean, you see that with other services too, though, to be fair, not just Mongo.
Oh
You
yeah,
can
other
find,
services have insecure defaults too.
I mean, I'm sure everyone's familiar, not that it's a security risk, but the Apache It Works page, you can find that all over the place. People who probably just set up their server and are starting everything. So my guess is people do this for all software. It's like we kind of talked about, though. I would venture to say it's because by default they don't need to really configure security too much. Mongo just goes that opposite route and doesn't secure much.
Yeah, I mean, and that's the thing. Like, secure defaults is something like when I work with clients, we look at what's your default configuration, and is your default secure? Not just is your current deployment secure, but what's your default and what should you change there? Because making security easy matters.
Yeah, no, and that's actually a pretty solid point. Is there are people that they use different things to deploy, in a fast manner, right? So they have a default image or a default installation, and if they can configure their nice one, it's all secure and everything. But if by default their base image has a very non-secure version of like Mongo or something, then you're just right back to waiting for that ticking time bomb. You know.
Yeah.
Yeah. So we'll move on from the
hmm
MongoDB leak, but these advisories actually have some kind of similar things. Just get really stupid pop-ups. Yeah, they had some similar silly security issues, insecure defaults. So
Yeah, I mean, there's over like 100 vulnerabilities in these.
yeah,
It's this came out of Hack in the Box security conference in Amsterdam. That was just Friday. Part of obviously the guy didn't go through everything here, but and unfortunately his slides aren't up. But these are the kind of vulnerability reports associated with kind of his finding, which are these building management systems and access control systems. Generally like their web applications for like controlling them.
yeah. So I looked through some of them. So I think there were 5 that were dropped on May 10th, and
Yeah.
like almost every single one of them, they had default credentials, like almost all of them. And
Yeah, several had default credentials, cross-site request forgery, or if it wasn't default, they had hard-coded things in there. Some had both default credentials and hard-coded crypto keys.
yeah,
Lord.
CSurf was in all of them. I think I might be wrong, but I think it was in all of
It
them.
wasn't in the Optergy Proton one.
Really?
It's the second one, yeah.
I was almost certain that I saw it in there, but maybe I'm wrong. Yeah, it did.
Oh,
It
I
had
must
CSRF
have
as
missed it
well.
when I was. I tried to go through all of them and write down what was in all of them, and I don't have
Yeah. So like,
CSRF there, but
some of the main ones were like default credentials, CSRF, XSS. One had an authenticated SQLI, and MD5 passwords was
although
another
that one
commonality.
the one that had the authenticated SQLI also had an authentication bypass.
Also, what? Sorry?
It had an authenticated blind SQL injection, but it also had an authentication bypass.
So those would be good to chain together.
Yeah. And it used
Wow.
MD5 for passwords.
Yeah,
Although I guess
a
it's
few of them use
better
that.
than the Nortec one that didn't even use. That had plain text passwords, I think.
How old
Yeah.
are these systems? How old is all this shit that they like? Not the
It
analysis,
sounds
but
like they're being actively developed because he mentions like reported and most of them got patched and then Nortec didn't patch.
I mean, good lord, if this is like very bad for something, anything this recent.
Oh yeah.
Oh,
Like,
it doesn't
this is
surprise me actually. I was actually kind of reminiscing because this is the type. It's a little application that most users aren't seeing. That's just kind of used behind the scenes. And like what I've seen with a number of clients is like, they'll have us testing their big thing, and I remember this one case client had us testing their application. They're like, hey, we use this thing. It's literally like, everybody uses this. Like, this is something that's being used by like, millions of systems, and it's like, it's built by this guy in his garage pretty much. It's this one guy, little web app. Would you guys mind? We're hosting it here. Like, they were running it, so it wasn't having us test someone else's prod system or something. Would you mind just poking at it quickly if you have some time during your test of this other application? Just see like its general posture. Every single input was vulnerable to something or multiple things. Like not even an exaggeration. Every single input we could find had some vulnerability from SQL injection, cross-site scripting, something. Everything was vulnerable.
Huh.
And I mean, I feel like it's actually really common because nobody really cares or looks at these because everybody's just using it for what it's supposed to be, and it doesn't have the exposure to actually be seen by people.
I mean, this system itself. What is it for?
This is building management and access control system, so it's would be used presumably by like
doors and shit like that. Like when you say building management, like literally like the doors that unlock and monitoring and shit like that, like the actual
seems like that. It doesn't go into a lot of details over what a lot of these are, just the name. These reports, like I really hope the report they gave to these companies had a lot more information, because otherwise these are terrible reports.
Yeah, they're very surface level. Yeah.
I mean, I could imagine this being delivered as a report. The sad thing is, like, if it was just a scanner or something that picked up a bunch of these things, I could totally see it, but I would hope it's better. I didn't really look into what the actual products were. I guess there is a link to the product page there, so we could actually take a look at that.
I guarantee you, if it's like that, like the building management in the sense of like automatic doors and crap like that, your web-based building controller. Yeah, dude, that's creepy. So
this was actually the most secure of the ones that
was.
I would actually disagree because this had the.
Oh no, this one did have that back door though.
Yeah, it literally had a shell that you could access unauthenticated. Like,
yeah, I was just
compromise.
I was just saying that as a glance because it had the fewest issues. Because most of these all have a bunch of issues, but yeah, this one had the back door, so not quite so secure.
I guess the back door is probably in case it gets bricked or some shit, and then like nobody can access the building or something stupid. Where they're like, okay, we should probably just put a shell here just in case everything goes to crap. But I mean, what the?
Completely unauthenticated, highest privilege. This was funny. I laughed when I saw this one.
Dude, it's like they told her like, well, no one's gonna look for this. We're just the door system. Like, who's gonna care? And then it's like, oh shit, never mind. There are people looking at this.
Security through obscurity is the best model. Totally.
No, I always enjoy a good backdoor, man. That's that's always the right way to run your business. Where you're like, if all else fails, put a fail safe for us to get access. Like that's actually I think
fail open.
Yeah, like I think you'd be surprised how often that is because people are so scared for products like this. They're like, okay, well, if it all goes to shit, we can at least hopefully jump into the system and do something, right? That's bad.
Yeah,
Bad
but
on
I
so
mean,
many levels.
usually they toss like a password in front of it, a pin, something in front of it, not just
Even the static password would
console.jsp.
be better than nothing. Like,
Hard coded password.
yeah, even a hard coded password would be better than nothing.
I mean, it doesn't sound like that's far off since all these are using either hard coded ones or default or whatever. I mean, you know,
Yeah, so just
it's
for some clarification, I did pull up the other one, the CompuTrolls page, and it looks like it's doing things like lighting and HVAC and access. So yeah, accessing like the doors, lighting, and all of that is the
I mean,
building management.
it's gonna turn into some Mr. Robot stuff, you know, where the when all the music's playing, she gets locked out of her house. Like that's exactly what I imagine this is like, you know, some idiot.
I was about to say this could be those kinds of attacks that you could see. I remember we talked about it before, not necessarily on the podcast, but you know, the Tiger Team stuff. I could see this being like part of that. Like trying to break into a building using these types of vulnerabilities in the panels and stuff. I actually think this would be really fun to like do in an assessment, but
No, I
Yeah,
think
I mean,
I
and
like
the thing is,
yeah.
these are usually such soft targets because most people just aren't exposed to these panels at all. I mean, I've never seen one. Um,
Yeah, I
like
don't
just
think
in
it's
my day to day, like I've never seen anybody using one of them. But obviously, many buildings are going to have them. Like it's there, it's just you don't have that exposure, so nobody really looks at it. And
it's that
that use
security through obscurity aspect, really. That's the only thing they have, pretty much.
pretty
It's the
much,
fact
yeah.
that people might not know if they
Literally
have them.
pretty much pretty much the only benefit they have is people not knowing they exist, most likely.
Yeah.
Yeah, I
So I
think a
mean,
lot of these have like command injection in there too. Like actually
there's
all of
like
them but the Optergy one, unless I missed that too.
probably everything in the CWE top 10 was in like every single panel,
Uh
or
OWASP
at
top
least
10?
almost. Or yeah, that's what I was thinking.
Yes. Well,
OWASP top 10. Yeah,
CWE's like, hundreds of common weakness enumeration. So
yeah. I was thinking of the OWASP top 10. Yeah,
yeah, that's what I
yeah.
thought.
Thanks for correcting me there. Um, yeah. So we'll move on from that. Basically,
Well,
the
just
big
before we move on, I do
okay.
want to comment on one of the issues: root access over SSH with hard-coded credentials. Was
Which
one
one
of
was
the
this in?
issues in there. That was in the very last Nortec one.
Oh, the Nortec one, and that was the one that they said they wouldn't patch, wasn't it?
Yeah, I know the first Nortec one definitely didn't patch. I think the second one was also, and it doesn't say they won't patch, just that wasn't patched yet. Very last vulnerability.
Let's see. Root access over SSH.
Mm.
Oh man, there we go.
I feel like it gets
Awesome.
I don't know. That's amazing. It's like every single one you read, it gets worse than the last one, where they're like, and we also
Literally,
wrote
yeah.
it on the hardware itself, the full hardware password, just in case you know, and then we mailed it to your grandmother for safekeeping. It's like, what the? How many safe measures do you need here? Just
You
put a
need
fucking
all of them. I mean, just in case you forget your password, you can definitely store it and just get it off the database really easily.
No, that's it. And if you forget it, you can just crack your own password if you need to. Since we're not either using any hashing or MD5 hashing. Dude, I mean, these are all just
Yeah,
features.
a few of these definitely use just MD5, or maybe it was just a couple, but still. Or no, one of them did pass the hash, so like you gave it the MD5 that it was storing.
Beautiful, dude. That's even better. You know, got to get creative with how you manage passwords nowadays, dude. There's too many people doing it the right way. Okay, we need the creative way.
Yeah, absolutely. I guess the biggest takeaway is just these systems suck, and
Basically,
Yeah, like I'm definitely not surprised by the fact that these are so vulnerable. It's always fun when they get pointed out. Like I always love reading just about these really terrible pieces of software. Because I mean sometimes it's just they fail in some of the weirdest ways at times.
yeah. I mean, I feel like there's CTFs that have more difficult problems on this stuff.
Oh, sure.
Yeah.
Like
Great.
DEF CON. DEF CON
Yeah.
calls were this past. Did you play it all?
No.
Yeah,
I heard a little bit about it. You know, there was still a lot of challenges that were just, you know, artificial inconveniences was like a
yeah,
big.
the guessing I heard. Yeah, I didn't play this year at all. I mean, I thought I was going to have to be working this weekend, so I ended up just forgetting that calls were even happening. Then it's like
I forgot
just
they were happening
browsing
too, to be
Reddit,
honest.
and it's like, oh yeah, in 6 hours, like calls start. It's like posted 7 hours ago. Oh yeah, and then at that, it's like, after my experience last year, I mean, the challenges aren't like, they're definitely not the worst thing I've ever seen by any means. Like, they're still miles ahead, I think, of whatever the CTF we had played. Not we talked about it on stream not that long ago.
I can't even remember the name of it now.
Yeah, I'm having trouble remembering the name of those two, but
It
like,
wasn't Sunshine, it was the other one, but yeah.
Must have been a great CTF if you guys can't
Oh,
remember.
oh no,
it was
they were
fantastic.
quite terrible. But
Yeah.
I mean, Order of the Overflow is definitely way better than that. I can't fault them on that. But like I said, definitely just some things that I just didn't enjoy their CTFs, to be fair. Like, that's what it really comes down to. I wouldn't nitpick it and say like I didn't enjoy it because they're all guesswork or something, like I would the that other CTF. In this case, I just didn't enjoy their style of challenges. It just wasn't very fun for me. So this year I just wasn't too excited to even play.
So you like legit BS a lot more as organizers?
I really like legit BS. I enjoyed almost every year. There was some challenge that I really enjoyed from what they had.
Yeah. Maybe they'll come back eventually, because this is the second year in a row. I think, yeah, this is the second year that Order of the Overflow has been doing it, right?
Yes,
Is it
this is their
second or
second.
Yeah, so I know there was a lot of criticisms last year, and it seems like they've gotten a little bit better, but there's still a few criticisms this year. So I wonder if they are going to still be doing it next year.
I think they signed a
Um,
contract to do it for however many years. I don't recall how long. I remember
Okay.
that was mentioned when DEF CON organizers were actually doing a call for CTF organizer. It was mentioned like you'd have to run it for so many years. I don't remember how many though.
Okay. Yeah, I wasn't sure if there was an actual. Well, I imagine there was a contract, but I didn't know if it was a yearly basis or if it was. Yeah, so that clears that up a little bit, I guess. Um, yeah, it'd be cool if we could pull that up. I don't know
Yeah,
if we have it.
I've actually just got it here. Obviously, I haven't read this in any sort of recent time period, but I'll pull it up. Which was back in 2017.
Let's see if it's. Yeah, I don't really see anything there yet, at least about the years it's running.
Yeah.
Oh, 3 to 5 years. Okay.
Well, that's not
So
necessarily saying they need to. It
yeah,
wasn't a commitment.
yeah, it doesn't
It was
seem like
just saying how
like a
long.
hard requirement. Yeah, it seems like you should try to aim for that. So
But yeah, so I thought there was actually a harder requirement on, like, that they had agreed at least like 2 years or something. And
yeah,
maybe it's in there, but I don't think we just want to do a reading stream.
All right,
yeah,
kids, get around. Gather around.
gather around. Yeah,
Reading time, kiddos.
yeah. So I mean, we'll move on from that. But I do want to move something up. I know we were originally going to talk about the CVE next, but I think, or yeah, sorry, the CVE
Linux kernel
2019.
race. Yeah.
Yeah, I think it might actually be worth talking about the Docker one, just because it kind of ties into the really bad security issues of the last report we read.
So I don't think
Which
this
was
one's
the,
necessarily that bad.
Oh no, it's not that bad, but it's a null password for the root user, isn't it?
Well, only
Still
in
not
some
great.
cases.
Okay.
So it's really important to notice that. So first of all, this is Alpine Linux inside of Docker. So this is a Docker container. This isn't something that's generally going to be listening out for like your SSH connections. Or at least not normally. Obviously, some people do set it off so you can SSH into your container, but That's not the normal thing. So anyway, what happened here was, essentially you could log in without a password. And where this really matters is more when as a privilege escalation. You've already compromised a container, you can do root, or you can get a root without a password. But I think it's worth looking at how they described kind of how this issue happened. If you look at kind of how it happened here.
I didn't actually see the response. I only saw the CVE report. So
yeah, I only saw this morning. And I mean, it sounds a lot worse, but when they explain it, like, okay, so they do have some security there, and they explain what happened here. They actually test to make sure root logins without a password are only enabled when you're coming in from a secure TTY. That way they can still boot Alpine on a machine, log in on as root without needing to ship any pre-generated password. So it's not just a default cred. And I kind of agree, or I don't entirely agree that pre-generated is worse than no password, as we were just kind of discussing.
I wouldn't say it is,
but it's not that much better. And services like SSH don't let you log in as a root with a blank password anyhow, but when a user installs, Linux PAM and uses that with Shadow, so Shadow will use the Shadow file as like its authority database. In that case, then Shadow and Linux PAM will accept that blank login. So that's kind of where it comes from. It's kind of a chain of things that need to happen. You need to be using Shadow and Linux PAM in order for that login to happen, which isn't the default by any means. And it's kind of an edge case for them. There's some they're already looking for. And now that's their edge case of, except when you end up using these things together, it's vulnerable. It sounds a lot worse than it is when you just say you can log in root without a password.
Which is what that CVE report basically said. So
yeah,
I think it should be updated.
Once they've described it, it makes a lot more sense kind of what happened.
Yeah, I mean, I do just want to pull that up just to see if maybe I'm misremembering, but I don't think they included those stipulations in there. It just said...
No, it just says something like it may accept a null password for root user.
Yeah, it does. Yeah, that needs to be updated. That's not a fair description, I don't think. Because it does seem very specific to certain.
Well, it does actually say there systems deployed using affected versions of Alpine Linux, which utilize Linux PAM or some other mechanism which use the system shadow file as an authentication database. So it does make it clear kind of when it is vulnerable.
Yeah. What was the score on this? Is it not on the page?
It's probably it. Oh, it should just be down a bit.
I thought so, but I didn't see anything. Let me see.
Yeah, I actually don't see it there. No CVSS.
Yeah, it's really weird. Anyway, yeah, I mean, that makes a lot more sense. I think the report should be a bit more nuanced.
I mean, that's just the description. I'm not sure what the full report looks like.
Yeah, I think they have it linked here. Let me just see.
It might just include vulnerable information. Yeah, it doesn't look like there's much.
Yeah, nothing too specific. Yeah, so I mean, it's, if you have an Alpine Linux container exposed and you use that setup, probably should patch it, but it seems very specific, so.
Yeah, it's still definitely an issue. It's also definitely an edge case. They are taking steps. They have patched it. I don't fault them for it all that much. It's an edge case. They've caught it now. They're fixing it. It's not like some crazy security vulnerability like root access over SSH with the hard-coded password.
Yeah. So we'll move on to a more interesting CVE, which is it's a Linux kernel exploit, which is always.
Do you have information on this one besides what's in here though?
So I looked into it a little bit. It's a bit weird, right? Because usually, so it says it's a race condition. So for those of you just listening, it's basically an issue in the TCP stack, RDS TCP kill socket sock in net. My bad. But yeah, it's before 5.0.8, and it's a race condition yielding UAF. So normally when you think about race conditions that happen in the kernel, it's usually due to like a missing lock or something like that. But if you actually look at the patch file, let me just bring it up. I'll bring up the GitHub one because it's a lot prettier. It's a one-line patch, and it's basically just a bad if statement. Yeah, right here you can see they just included the condition that they shouldn't have, and I'm guessing it's because that TC object they don't have ownership for. So that T_sock member that they check cannot be trusted, because if some other thread is running, it can corrupt that to make that condition true to cause the UAF. So I thought it was kind of cool, like funny, that it was literally just a one-line patch, and it was just like a condition that they had that they didn't need that was causing the issue.
Yeah, I mean,
Which I
that's
have
just
seen
kind of a
before.
statement to how subtle some bugs can be. I mean, this
Oh
definitely
yeah,
isn't the
like
most subtle bug I've seen.
yeah. I mean, I remember it's funny because the WebKit exploit that I wrote a couple months ago that I still haven't put out the write-up for because I'm really lazy. It was actually a very similar issue. Was it had a condition in a statement that was deprecated, that changed or whatever it was, and that it wasn't needed, and it could be abused to cause like a use after free, and that's kind of the similar case here. So yeah, just a testament to how subtle some bugs can be. um and obviously because it's if it's in the network stack, it is network accessible, so this could be used for RCE. So the base score was 9.3. So
Nice.
yeah, pretty big vulnerability, and such a small fix, like such a small patch. So
Yeah, at least it's an easy patch.
yeah. I'm not too like I would like to go a bit more in depth on it, but I'm not too familiar with that area of the kernel, so it's I can only really go off of like the patch and like what I know about races. So yeah, my best guess is this TC object, because this is another thing I do want to talk a little bit about in Linux kernel. It's easy to make mistakes when you have macros like this one. So you see list for each entry safe. Okay, this safe keyword, it's kind of misleading, because when you see _safe, at least for me, when I first started looking at Linux kernel code, when you look at that, you think that it's safe against races and stuff like that, right? Like it acquires a lock when iterating the list, and you don't have to worry about that kind of stuff. But that's actually wrong. This
You've never
_safe
written
keyword.
PHP, have you?
Well, actually, it's been a while since I've written PHP, but yeah, I mean that
Well,
safe
I only
keyword.
mention it because there's a function there that I'm thinking of, like MySQL real escape string or something like that, and there's MySQL safe escape string, things like that in
And they're
there.
not safe.
Oh no, the one is, and one isn't.
Oh, okay. Okay.
I think it's the one that says safe though, if I'm remembering the function correctly, isn't the safe one. But sorry,
Of course.
go on.
Yeah. But yeah, it's basically just that looking at that, you would think that you definitely have to, at least if you're going to use the node that could be used somewhere else, you have to lock before iterating a linked list like that. So they probably could have kept this condition in there if they needed it and just added locks around the list iteration, but even then that's not entirely
That definitely
guaranteeing
adds
safety.
like a lot of, or it gives you a performance hit though, needing to lock every time.
It's a performance hit, but the other issue too is a lock is only useful if you lock everywhere that you use that object. Like, even if you put a lock around that list iteration, if there's somewhere else that uses that object that doesn't lock, then it's useless. So that's why races are so prevalent in kernel. It's so easy to make like assumptions and stuff like that. Um, but yeah, pretty interesting bug. It would be cool to try to exploit that. I don't think there was no exploit
Yeah,
POC
there
published this time.
usually isn't.
Yeah, too
As far as
bad.
I know, there is, and I mean, maybe we'll see one on ExploitDB come up,
Maybe
or
we'll
just
write
write
one.
one. I mean,
Yeah, we'll
it's
just write one, put it out. I mean, it'd be
yeah.
fun. So
I mean, it's
yeah,
a good. I think starting with something like this is actually a really good way to work on exploit dev skills, because you know there's an issue, you know where it is. Now exploit it. and it's a real world issue. I mean, so that's actually
Yeah.
something I totally recommend people do. It is a really good way to get up to speed.
Yeah, so I mean, I think we actually talked a little bit about this before, maybe not on the podcast, but in a chat or something. We're basically saying somebody was trying to get into kernel exploitation, and they were like, "How do I do it?" And they were trying to read a bunch of books and stuff. And it's just like, well, this is a perfect way to do it: is look at endays, try to exploit them, and you learn a lot through doing that. And especially in these kinds of bugs where you're literally given the exact location from the patch, like the commit difference, like that's perfect for trying to learn exploitation and exploiting real world kernel stuff. So if you're interested in that, this is like a perfect issue to start with. So yeah,
Yeah,
from
no,
there we'll
it's a really good way to learn. I think is just dealing with real exploits and rebuilding them.
yeah, and perhaps I might even try to do that with this one just for fun, just because I like races. So yeah, we'll move into the last topic, which is the arbitrary file read. So this was kind of a last minute addition. It was published today, so I didn't really
Yeah,
get a
I
chance to read it much.
read this morning. I thought it was kind of I was first kind of keyed on just because of the bug itself. Is
Okay.
the picture isn't great here, but it's in the accept header. Wait, and that's from the client, which usually, like, you're using accept to be like accept text/HTML, like, send me HTML back or application JSON, whatever. You're giving it some MIME type for it to read back to you, or for it to use when it comes back to you. It's not really a header that is generally where you're going to look for a vulnerability in.
It
And I
doesn't seem like a
guess,
common vector, no.
yeah, and so I guess at that, the issue is actually there's a Ruby on Rails CV for the same issue back in March. So this is just an instance of it in Hackerrank, where I guess they're using either old or unpatched Ruby on Rails, presumably patched now. But anyway, so generally, like, that's not somewhere you're really looking for issues. And I thought it was really interesting because what happens here is essentially what Ruby on Rails would do when you call, like when you want to render a template, you can go and tell like render and then template name, and it'll go and it'll try and intelligently find the file. It'll look for like template name.html.erb or layout.xml, whatever it is, and it'll use the information from the accept header. It'll use that to figure out what template it should look for.
Okay.
So that's where this accept header ends up in like this regex where it's looking for that file. So it ends up being in there where it's looking for a file name dot the MIME type that you provided here, the accept header .erb. That's where you're able to get that path injection out. So I thought that was just a really neat little bug because it's not something you see super often. That's also why you've got like the tags in there. Ultimately just kind of works with the larger regex. And there's
Okay.
I think this thing even links. I think it's this one that kind of goes into more details about the actual issue. Or
That's kind of an interesting.
one of these links kind of goes into detail about the Ruby on Rails aspect of it.
That is kind of interesting though. So like the one that we've shown is basically just like a file disclosure, which is pretty big already, like disclosing the password file. But I found it interesting that they said that they can combine it to perform RCE. How does that?
Yeah, I didn't
That's
dig into
interesting.
quite how they'd get that. I would have to assume like Ruby has, if it does any serialization, which it very well may. I know Ruby has like a universal deserialization gadget that
Okay.
can be used, and let's just see here.
Yep.
Yeah, okay,
There
so
you go. Good guess.
deserializations. So obviously this uses some serialization somewhere in. And that it has a fairly decent write-up here, though,
Okay. Yeah. So we'll link that as
about how
well
to craft
for
it.
anyone
Kind of
interested in
goes
that.
in there. Well, it's linked as part of the other one.
Yeah. Okay. Yes.
Like it's accessible. It's there. That's kind of how I got my really quick rundown over how it worked. Maybe I'm misunderstanding what the two curly braces were for, though. If that had to do with the serialization, not a regex, as I initially thought. Either way, I thought it was just interesting. That's how the file, like that's how this MIME type ended up leading to a file disclosure. The other thing, though, like it's an interesting little bug. Since you didn't have a chance to look at it, I don't think we can really go too much into that. But at the end here, Hackerrank responded that the flaw has been completely fixed and can be disclosed on May 13th. But no bounty was offered, but a t-shirt may come. And, in this case, like, okay, he's not really asking for bounty, but even just bringing it out there just seems a little bit tacky to me. And just like, oh no, it's a pet peeve of mine where people come along and they're like, I found an issue, now pay me. Hackerrank does not have a bug bounty program. They used to have a HackerOne, but they do not have a bounty program anymore. That means like this guy went onto he exfilled Etsy password on a production machine on a system he is not hosting, that he does not own, and that he does not have authorization to test on. Yes,
so that Reddit.
I'm glad that. Yeah, I'm just gonna say I'm really glad that companies aren't taking the immediate just arrest them response. But this is why they do it. This guy literally just went and compromised one of their servers. Yes, in a minor way, and yes, he did a kind of, he did the right thing by reporting it to them. But he also kind of overstepped by doing like the testing at all. No doubt he did more testing than just this one issue. I mean, very well he might have, but more than likely he was actually trying to assess them and all of that. Very much illegal. And I'm glad companies aren't arresting or jumping on just arresting people so often. But like this is also really clear cut. Sorry, you're going to say something about Reddit?
Oh, I was just gonna throw in that Reddit comment meme. That's illegal. I guess that it's a lot more true in this case than any other case.
Yeah, no, it literally is illegal here. Of course, I actually tried to point that out on Reddit, and oh no, I've definitely been in the negatives because of that. Like I said, this is definitely a pet peeve of mine, just because don't go break the law, even if you have good intentions. Just respect the law, respect the boundaries that they set. If they don't have a bounty, just find somebody else that does. But I mean, I had responses so I kind of related this to it would be similar to somebody breaking into your home and taking a piece of paper off your desk and then coming back and being like, hey, I could have done much worse. I could have stolen your TV, so you should pay me. Well, and I feel like that's reasonably accurate. I mean, obviously metaphors, they fall apart. But I mean, I got responses here, and I don't know what people are thinking of or what they think this guy did, but one of the replies to me was, it's exactly like somebody found a picture of your house, saw your social security number and Wi-Fi passwords on a post-it note in that picture, and told you about it so you can get fixed. No, this guy, he didn't just see it. He actively, used a Ruby on Rails exploit to get this file. It's not just he saw it. Or another guy told me, no, it's totally like your neighbor telling your neighbor to close the curtains when he's having sex. I mean, honestly, well, the idea being you see things that you don't necessarily want to see. Like, that's not...
Yeah, which is not true.
It's an act of action. Like, he did something here. I don't get why, like, my opinion here is so controversial. I mean, you don't break the law unless you want to have broken the law. Don't break the law and then ask to be paid for breaking the law. I know it's kind of accepted in our industry, but I really think we need to hold ourselves to kind of a higher standard, just to encourage, because bug bounties are a great thing. I am not against bug bounties. I think it's a good thing. I think companies should have them, and that just on a whole, it's a sign of a mature security posture for a company to have a bounty. But when they don't have it, you're not going to get them to have a bounty by, extorting them for, whatever he found.
Yeah. Now I will say though, like it is just that little line that no bounty was offered. You could argue that, like, playing a bit of devil's advocate, he was just saying that to, you know, like for full completion of the article. Like
Yeah,
it's not like it's not he didn't say directly like I expected to be paid or anything like that.
yeah,
Like
to
it
be
is kind of a
fair, I
cheeky
don't
line.
actually take an issue with this guy all that much. That's just a side issue mentioning about kind of the bounties and stuff, but
Yeah.
no, like this guy generally, like, I mean, he shouldn't have been testing in the first place without a bounty.
Yeah.
But otherwise, like, he did everything responsible. He did things correctly in terms of how he responded to
Yeah.
it. It's just, I mean, he shouldn't have been testing. Like, that literally is a crime. Like, it's not maybe a crime, it's not partial. It's full stop, it's illegal. And
Yeah.
I mean, in the late 90s, early 2000s, there weren't a lot of ways to really learn without just going out and testing, and there weren't bounties. I mean, the only way to really learn was through breaking law, but nowadays you don't have to do that. I mean,
Yeah.
there's so many ways to learn now without breaking the law that I can't stand behind it the same way I used to.
Yeah, I guess I can see that stance. I mean,
I mean,
like you
especially with
said,
so many companies having bounties too. There's so many targets you could go for that will pay you.
yeah. I mean, yeah. I mean, this line is kind of cheeky. It is really subtle though, and it is at the very end, so I can't critique it too much. But
Yeah, and like
I
I said,
mean,
I don't think he's necessarily like a big issue with this one.
yeah,
It's more kind of just it's more a comment on in general rather than like he didn't seem to actually expect a bounty out of it. Like, to be completely fair, I don't hold that part of it against him. Report it, found it, report it, great. Um, yeah. So I kind of wanted to
yeah,
touch on that though, because, like I say, it is absolutely a pet peeve of mine. It is something that I want to mention because I don't get why it's such a controversial issue in the industry for me to think that people shouldn't demand money or shouldn't expect it. Again, to be fair, he didn't actually, or all the evidence we have indicates that he didn't demand money or anything. He reported it. Things were mutual and all of that. Like, nothing indicates that he acted unprofessionally, except for the fact that he was testing when he shouldn't have. It's
yeah,
that's just the side issue I wanted to bring up and force in here.
that's fair. Yeah. Yeah, so I guess we'll wrap up the stream there. That was our last article. So thank you all for tuning in. We will be back again next week. Are you guys good for next week?
Yep, we'll be here next week.
Should be
Okay.
good.
Yeah, so we'll be back next week at 12 p.m. Pacific, 3 p.m. Eastern. And
Hey, you
yeah,
got
so
the times right. I never do.
I know I almost did. I was like, gears were turning when I said that. I hate time zones. But yeah, so that concludes this podcast, and we're gonna see you guys next week at the usual time. And yeah, we'll see you then.